Problem F is about how to get from initial state of some table with letters located in its cells to another final statement of this board with the same sizes and letters located in other points. We could do some actions over the board, kind of shaking it. We could make all letters in the board goes down or right or left or up. For example, if we shake this board down, then we got this board. If she shakes this board on the left and make all letters go to the left, we'll get to this state. First of all, we need to analyze what kind of actions are actually, reasonable. For example, if we will make two consequent, movements in the same direction, for example, shake the board 2 times on the right, it actually doesn't make sense because we could just make only one action and this will give us the same result because all letters after first right shake is already on the right side. Also, it doesn't make sense to make actions in opposite directions. For example, you will shake on right then on the left. It is the same as just shake on the left once without previous action. Also, it doesn't make sense to make the same action after 2 moves, because if you shake board on the right, then on the up, then it doesn't make sense to shake it again on the right because all letters are on the right, because movement in other in perpendicular direction doesn't change anything, in terms of being on the right. If we'll continue this case analysis, we will see that the only reasonable way to make actions is to make them kind of in clockwise or counterclockwise direction. For example, we could shake right, then up, then left, then down, then again right, up, left, and so on. Also, we could do it in opposite direction, like right, up, left, down, and so on. So we have not so much that we can do. We could apply clockwise or counterclockwise approach, or just decide to make some number of cycle actions and then not more than 4 other actions. Okay, one more thing that we need to realize to solve this problem is that if we do some cycle, not in the initial state where the books could be spread over the board, but for example after they are in some corner like here. So if in this case we'll apply some cycle clockwise or counterclockwise 4 actions, after we will do it, shape of the figure of how letters is located on the board will be the same. And it could be proved by analysis of how books are distributed. This will help us to understand that actually when we apply a cycle, we will just permute letters located in some cells between each other. So we could split all cells in several cycles in permutation and analyze them independently. Every cycle in this permutation could be analyzed as a string of letters that we have in the beginning. For example, A, B, A, and for example, in final board it should be, for example, B, A, A. And in this case, we know that we need to shift this string on the left once time, and also we could do any number of actions which is divided by 3. It doesn't change anything because length of this cycle is 3. Okay, so we could analyze how from initial string we could get final string if there are no, again, cycles inside the string, like cycles like this one. Then there will be only one way how to do it. Otherwise, it will be either 0 ways to do it. In this case, this is impossible if the structure of strings are too much different. Or if one string is shifted on another string, then always you will be able to reach it after some moves, modular length of the shortest cycle. Shortest cycle and this constants easily could be defined by some prefix function or that algorithm over these two strings, and then we should just merge results that we'll got from different cycles of not cycle trajectories of this permutation over the board. If they are not contradict each other, then always answer is yes. Otherwise is no.